Here's 1, 2, 3. Okay, test 1 2 3 test 1 2 3 okay ครับ good afternoon everyone, welcome to EE111, which is mathematics for engineering 1 And we arrive at the fifth chapter that involves many stuff that it uses เดี๋ยวนะครับเสียงกล้อง okay yes it involves many stuff from the previous chapter. I don't know whether the sound works well or not, but I'm gonna hear you by using another headphone. Okay. The fifth chapter will talk about calculus of a real valued function of two variables. Let me check whether the sound works well or not. Okay. I don't know which one. This one. Okay. The sound works perfectly. Okay. And okay, let me lay down here again because someone may would like to enter the Zoom classroom. Okay. The fifth chapter will talk about calculus of the real value function of two variables. Okay. Yeah. The real value function will serve as many basic or basis to several subjects in two variables will be the first extension for you to see the various dependence, okay, several dependence on many factors or many variables. Okay, let's talk about the contents in this chapter. I hope that I sent you already the lecture note right here, the fifth chapter on the group line, and it's also available in the oh no, where is that? I know how. Okay, in the Google Classroom in EE111, right? Yeah, the seventh lecture, the lecture notes is also provided here. And yes, the topics in this chapter will include a speed of motion along helix. Okay, you have got to know helix, right? It's like, it looks like spring or coil in electrical engineering. It looks like spring in mechanical engineering, and we assume that an object move along the spring line or the helix line, and we are gonna determine the speed of the motion of that object along the helix path. Okay, and we will consider again an example of the arc length. Once we want to find the distance of any function on the graph in the xy plane only. The next one will be the limit. Okay, this one is difficult. Okay, it involves a lot of difficult thing. คนนี้ที่เป็นลูกครึ่งนี่คือชื่ออะไรครับ partial derivatives will be the further step for us. We're gonna introduce the new operator, which is the curve or partial derivative operator. It's like it looks like เหมือนกับออ่างและวอแหวนผสมกันนะครับตัว curve นะครับเตรียมเขียนไว้นะครับ Okay, and we will consider higher order partial derivative. This is the first order only. We consider second, the third order derivative in the last section of this chapter. Okay, yes, let's start with our first topic, the speed of motion of any object along the helix. Assume that we have the vector, the position vector of an object as vector rt. Please note that the bold symbol represents the vector. It has three components along the x-axis, y-axis, and z-axis, right? The first one, please note that this is the angle parenthesis. That's the vector. The x component is denoted by cosine of t, and the y-axis is denoted by the sine of t, and z-axis is governed by the variable t. Okay, it's positive along the z-axis. Oh, I'm sorry for that. I forget to share the screen, right? ผมลืมแชร์หน้าจอนะครับ ขออภัยด้วยไม่มีคนแจ้งเลยนะใน Zoom นะครับ I forget to share the screen. I'm sorry for that. Right. All right. Yes. Yeah. พูดมาซะเยอะแล้วนะ Okay. The first example we talk about the helix motion and the position of any points along the helix will be given by or controlled by the vector r, which is the position vector, and x component is given by cosine t. เดี๋ยวจะรอดูคนนะครับว่ามีใครจะเข้ามาอีกไหมครับ and y-axis is given by sine t, and z-axis is denoted by t, okay, positive along the z-axis. And yeah, that's the position vector of an object that moves through a helix path. And we want to find the speed of this object. Okay, and if you don't understand completely, I may write down something. Okay, let's say this is the z-axis, this is the x, y, and z, right? Positive here, positive here, positive here, and helix will be something like this, something like this, right? It looks like string, but with only a single round, okay, with only one complete rotation, okay, and we assume that an object which is denoted by the blue object here just move along this helix path, and it could stop only here or even go further. Okay, it's up to them. And they want to find the speed of the object, the blue object here, that moves through this path. And as you know, the speed is given by the norm of that object, right? Of the position vector of that object. In yes, we will follow that task easily or directly. Yes, the dot here is the derivative with respect to right? This is d by dt, and vector rt will be the same. Okay, then we write down the vector whether in the angle parenthesis or in the square bracket like this. Okay, cosine as the first component, sine t as the second component, variable t as the third component here. And after that, we distribute, okay, we move d by dt to these three locations, these three components. And d by dt will stay in front of cosine t, d by dt will stay in front of sine t, and d by dt will stay in front of variable t. Next step is that we will make the differentiation. Okay, we differentiate the cosine t, right? We differentiate the cosine t, and we differentiate the cosine t in sine t in the second component and variable t. And as you know, the differentiation of a cosine function will be minus or negative sine t, right? And the differentiation of the sine t will be cosine t. Differentiation of t with respect to t, of course, is quite easy. The power of 1 will reduce to 0, and t with the power of 0 will remain number 1. Okay, and yes, we get something like this. The next step is that we're gonna need to compute the norm operator. Norm operator will be computed by the square root of each component square. Okay, the first component is squared, the second component is squared, the third component is squared like this. Okay, with the power of 2 or square. And after that, you can see that even it has negative symbol here. Okay, once we make the power of 2 or the square, we're gonna have positive quantity. And yes, you know that 1 square remains 1, and here is cosine square, quite simple. And from the trigonometric identity, sine square plus cosine square will be number 1, right? So once we have number 1, it's going to be 1 plus 1, right? So once we have 1 plus 1, we would get square root of 2. Okay, that's the 1.4. Okay, numerically, and that's the approximation 1.414. Okay, so the speed, the magnitude of this, or the speed of this object. Okay, the object will move along the helix. It will move with the speed of 1.414, I would say, distant unit per distant time. It depends on what is the unit along x and y. If it is meter, so it's going to be meter per anything per second or per whatever time unit you want to consider. Okay, the next one will be the problem. Okay, it's parity now. After 15 minutes, I'm gonna remove the Zoom. Okay, I will not wait for anyone else. We will not wait for anyone else. We are gonna consider the problem of arc length determination. Okay. Before we go that, we need to know some basic integration results, which are required in order to solve this problem. So the first integration result we need to know is the square root of x squared plus 1. Okay, square root inside. X squared plus 1 inside the square root, and r is divided by x. It's gonna be okay. You may use the technique of integration, 3 integration techniques, right? It's partial derivative, change of variable, and trigonometric identity. You may use those 3 techniques to solve this problem. Okay, it has change of variable, oh my god, change of variable, and by-part technique. Okay. 3 basics in 3 methods, 3 techniques in integration, right? And the third one is the trigonometric identity. You need to know the property of trigonometric function. like this one. Okay, if you don't know that the sine square plus cosine square remain number one, so it's very hard to solve this one. Okay, and yeah, the last technique will be something like that. Okay, and after we use these three techniques, we're gonna find the results, and you may look at the result from any textbook. Square root x squared plus 1 and x, right? If you don't believe this, okay, we may go to any website. Here, integration calculator. Okay, you may go to that. Okay, here, and the function. Where is that? Oh, here. The function that you may insert into this one is square root of x with the power of 2 and plus 1, and after that divided by x. Okay, and then you compute. Okay, you will get the result like this. Okay, here is the result, which is the integration results, and yeah, you may check it whether it's correct or not. Okay, ln absolute, right? The ln absolute will be held for only the negative term. Okay, the difference term, and just you have the positive as the denominator, and you could see that difference of the ln. Okay, this one will stay at the denominator like this. All right, and it has 1 by 2 in front of that. Okay, 1 by 2, and the next term is square root x squared plus 1. Okay, square root x squared plus 1. And the constant, right, C1, right here, they just write down C because they have only a single equation. But for us, we have two different equations. We need to introduce two different constants, C1 and C2. Okay, and yeah, it's the result from integration. And for the second one, you may write it here. Exponential, right? Exponential of 2x, right? 2x, and we would try to see the result. Yes. Oh, why? Okay, now the result. No, this not the result. The answer is not greedy. They could not find the answer. Okay. They couldn't find the answer. It's no problem. We go to the next website. Okay, Wolfram. Okay, here with this website, Wolfram. With Wolfram may be more powerful than that. a square root, right? Square root of exponential with the power of 2x and plus 1, right? And the whole square root is divided by x, right? Oh no. Oh, I put the wrong one. Okay, there is no division of x at all. That's why they couldn't see, they could not find the answer. Okay, now we get the answer. Just the answer will be the ln of the square root of x plus 1, right? And it's negative. Here, negative means here we have 1 by 2, and here is negative. Negative means this one will stay at denominator, and this one will stay at numerator right here. And both have 1 by 2. Okay, we have 1 by 2 plus here. And this one will be the term, this square root of e with the power of 2x plus 1, and plus the constant c here. Okay, and that's it for the integration result that we need to know before we go ahead with this problem. Okay, by the length of the curve given by x, given by y equal to ln x. Okay, you know ln, right? Is the natural logarithm function of x in from x equal to 1 to x equal to 3. Okay, let's take a look at this problem. Okay, from 1 to square root 3, you know that square root 3 is 1.731, right? 1.731 is the square root of 3. Okay, the function ln x, okay, natural ln x start from minus infinity and it reaches number 1 here. Okay, once y is equal to 0, when y is equal to 0, x should be 1, okay, because exponential of 0 will be number 1, right? So but the length they want to know is from 1 to square root 3. Okay, it starts from 1 to square root 3. This is the whole function y equal to ln x. Okay, to ln x here. And yeah, we consider the x for only 1 until square root 3, from 1 until here 1.731. Oh, 732, sorry. And what else? Yeah. What is the length of this curve? Okay, please note that this is not straight line. It's not straight line, it's a curve. Okay, and what is the length of this portion? What do you think? How could you find that? Before that, we know that we could find any length from the fourth chapter by using this formula, right? Where is that? Sorry. The fourth chapter. Okay, let's get back to the fourth chapter. And we could find the length of any function from this one, right? Now, the length, right? The arc length, the length of any curve will be integration from a to b. Okay, and the norm of the derivative, okay, differentiation of the vector function of t with respect to t. Okay, that's the integration with respect to t and differentiation with respect to t2. And yes, how could we find the curve length of this one, ln x? How could we find this one? The pink or the magenta curve here. Yeah, because we need to know the vector f, right? And we should set up the variable t. But from what they have provided is only y equal to ln x, but they want to know this path. Yes, the way to solve this is the following. Should we start from the integration of ln x dx from 1 to square root 3? Is that correct? Is that correct? อันนี้ถูกไหมครับการหาส่วนโค้งของฟังก์ชัน y เท่ากับ ln x fx นี่เท่ากับ integrate ln x จาก1ถึง √3 ถูกไหม Is that correct? ถูกไหมครับถูกไหมเอ่ยไม่มีใครตอบเลยนะครับ The answer is wrong. Okay, the integration will mean the area under the curve. Okay, it means you are trying to find the area here. Okay, and that's the integration. Okay, but it's not the length of this curve. Okay, it's the area. So we could not use this formula. We have to use this formula. Integration from a to b, norm of differentiation of ft with respect to t, and integration is made with respect to t2. Well, yeah, we have to use this formula as I told you, the equation 37 from the 4th chapter, and yeah, it involves the integration, the norm, differentiation. And before we go ahead, what should the vector function ft be? What should we have for function ft? It is also a vector function. Okay, it's not a scalar function. You would be able to differentiate between scalar function and between the scalar function and the vector function, right? Okay, what should ft be? Let's say ft represent the portion along the x-axis, which is xt, portion along y-axis, which is given by yt, portion along the z-axis denoted by zt. Okay, and now it's time to choose what is x and y in order to go along this path, this route. What should ft be? Okay, you know that the first component represents the portion along the x-axis, right? How could it go along the x-axis? When x is large, it's x, right? x is denoted by x, right? And yt will be this value, okay, ln x. And what about zt? Is there any movement on the z axis, along the z axis? No, they don't change. It doesn't change its value along the z axis because it takes the values for only along x and y axis, okay, on the xy plane. So there is no motion along the z axis at all. So we're gonna say zt is 0, and there are two ways to assume x and y. If you prefer x, okay, that's the first method. If you prefer x, you let x be t, and y, oh, I'm sorry for that. Oh, อันนี้ไม่ได้แก้อันนี้ผิดนะครับ อันนี้ต้องเป็น y นะครับ okay, y is equal to exponential of t, okay, ทำไงได้เดี๋ยวแก้ทีหลังนะครับ this is y, it's not x, okay, and y is equal to exponential of t. The first one is that oh no, it's already correct, I'm stupid. Okay, when x is equal to t and y is equal to ln t, okay, we use this function. We let x be t, okay, and y will be ln t because x is equal to t. This is the first method. And for the second method, you know that when y is equal to ln x, you can write it in another way, that x is actually exponential of y because you take exponential to both sides. You will get exponential of y equal exponential of ln x, and furthermore you will get exponential of y equal x. Okay, and once you let y be t, you let y be t, and the outcome of x will be exponential of t. Okay, that's the second method. And okay, we will solve this problem by using both method number 1 and method number 2. Okay, method number 1 and method number 2, right? Two different methods, but in whatever method you should get the same answer, right? You should get the same answer.โอเค เดี๋ยวนะครับมีคนส่งหนังสือมาให้ผมนะครับ หนังสือแก้เกรดโลจิสติกปี 4นะครับwhere is that เก็บไว้ที่okay, later we will do it later ไม่เป็นไรครับ okay, we have two methods, and let's start with the first method. Okay, we go ahead with this method. When x is t and y is ln t, so we write down here, okay, yeah, x is a function of t, y is a function of t, z is a function of t, but there is no movement along the z axis. Zt will be 0, so we have 0 here in the third component. Y will be ln t, okay, because yt is ln t, and xt will be t, right, like this. Now we could use the equation 37 right now. Okay, equation 37 say integration of f okay, f of the first method, this one, and integration from when x start from 1, x start from 1 to square root 3, so t will be also from 1 to square root 3 because they are the same variable here. Okay, x is equal to 3 to t. So once x is from 1 to square root 3, t will be also from 1 to square root 3. We have the integration limit for this integration as lower limit as now 1 and upper limit as square root 3, which is 1.732. And here will be the same as equation 37, the non-numerator differentiation with respect to time or to t, and f from the first method. And now we substitute the vector from the first method into the norm and the differentiation. And the next step, as you know, we distribute the differentiation to each component, to variable t, to ln t, and to 0. And once we have distributed the differentiation operator to each component, we make the differentiation, we call it the differentiation, right? Differentiation of t with respect to t will be number 1. Differentiation of ln t, natural logarithm of t, will be 1 by t. So we get the first result, the second result, and differentiation of 0, of course, will remain 0. And once you have 3 components inside a vector, it's time to compute the norm. Okay, the norm will be square root of each component square, and they sum up together, we get the sum of these 3 things. The first one square, right, and the second one square, the third component square. Okay, 0 square will remain nothing, and 1 by t square will be 1 by t square here. 1 square will be number 1, and you just try to compute the summation here. T square will appear here, and you will get 1 plus t square by t square. And we're gonna move the t square outside the square root. Is gonna be 1 by t only without the power of 2, because this is the square root. And let's take a look at the integration identity. The integration identity, right? Integration identity says something like this: the integration of x squared plus 1 divided by x will be blah blah blah. But what we have here is integration of t squared plus 1 square root and divided by t. Can we use this identity, or should we use this identity? And of course, you're going to see that the first formula will correspond to our situation right now. You just look at t as variable x, it will be the same. And we have plus c as the constant in the, how could we say, it's in the finite integral. Okay, it's in the finite integral. That is a constant. Okay, the integration without limit, we should have a constant as its solution. For us, yeah, we have the finite integral, right? So we're gonna pick up only these 2 terms, but in terms of t, variable t. So we have the first term and the second term. And one thing we need to know is that the first one, the difference should be with the absolute value. And this one is often positive because t squared should be greater than 0, and this one will be greater than 0, greater than number 1 all the time. And yeah, the upper limit is square root 3, the lower limit is number 1 according to the limit integration, and after that you compute something. Okay, you distribute square root 3, you substitute square root 3 to the variable t in both locations, and we will get okay, of course the first one will be square root term, right? We have square root 1 square plus the natural logarithm like this, and the difference of the first two terms, okay, square root 3 plus 1, square root 1 plus 1, right? It's, you know, square root 3 plus 1 is square root 4. Square root 4 is positive number 2. And here you just leave it, okay, and here is square root 2, right? And yeah, square root 3 plus 1 will be also 2 here. And 2 minus 1 will be number 1, and 2 plus 1 will be number 3. Square root 2 minus 1 and square root 2 plus 1 will be the result here. And square root 2, 1 by 2. And here we distribute as the difference. Okay, ln 1, ln numerator minus ln denominator. And here too, ln numerator. But this one is negative, so it's not negative here. It should be positive. And ln of square root 2 plus 1, okay, as the last component. And in some case, you may have to solve this problem in terms of logarithm of complex numbers or negative value numbers. If you have a problem in order to solve the directional logarithm, whether your argument or input is complex or negative value, you have to use this one. It's got to be equal to r times exponential of I theta. And once you distribute the ln logarithm, natural logarithm function, you would have ln r for the first one. And for the second term, the result will remain only I theta, and I is the radius of this complex number or negative value, and I is the square root of 1, and theta is arctan im by real. Okay. And once you get this result, okay, the next procedure is that you know that ln 1 exponential of what number will give us number 1, so exponential of 0, right? And we get minus or negative ln 3. And yes, you combine these two terms together, this is negative, and we move negative out of these. Is going to be minus 1 by 2 ln 3 plus square root 2 minus 1 square root 2 plus 1. And if you put this term into calculator, you're going to get the arc length 0.9179. So the length here of this curve is 0.9719. All right. I hope it's not so difficult. Yes, please remember this number. Okay, we will continue with the second method. In the second method, we use y as variable t, and y is equal to x, right? It's equivalent to y is equal to exponential of t, and we don't have any value for the z axis at all because the curve just stay onto the 2D two-dimensional system. So now it's time to make differentiation, right? Okay, the calculus for the beginning, it will be like this. Xt is exponential of t, and or t is equal to ln x. The lower limit x equal to 1 means a is 0. Okay, we are talking about the limit. Okay, yeah, we could not use the limit for x at all. X is equal to xt is equal to exponential of t. Okay, when x is equal to 1, it means the lower limit will be 0. And once we have x equal to square root 3, we were going to have square root 1 by 2 and ln 3. Okay, now it's time to make the differentiation, and a and b will be the limits in that integration. You start from 0 to 1 by 2 ln of number 3. We make differentiation, and differentiation of 3 component exponential of t and 0. We distribute or move the d by dt to each of these to all 3 components, and we get exponential of t with respect to t will be e with the power of t. dt by dt will be number 1. E exponential of 0 by t will be 0, and it's time to make it's time to compute the norm. Okay, the norm will be square root of exponential of t square, 1 square, and 0 square. And of course, this one will be exponential of 2t, and this one will be number 1, and here is still the 0, right? And we get the result like this. And now we move to the identity. Otherwise, you're gonna get stuck with this. We have also provided the integration identity right here. Okay, exponential of x square root of exponential of 2x plus 1. Okay, 2t plus 1. So it's not the same variable, but we will look at this problem as variable x or variable t, up to you. Because it doesn't matter. Okay. Okay, exponential, the integration of this square root and from 0 to 1 by 2 on 3. Well, find the length of the curve. Oh, sorry. Now we will use this expression. Yeah. Okay. Of course, we have used it. This integration result. Okay. Exponential of 2x or 2t, right? Plus 1 from 0 to 1 by 2 ln 3. And here is 1 by 2 ln blah blah blah. Okay, negative above. And yeah, this one will be 1 by 2 ln 3 as the upper limit. And when you substitute the value, you get the first term first, right? Exponential of this one, right? And exponential of 0. And for the third term, we distribute 1 by 2 ln 3 into this one too. And yes, of course, the same term. And for the second limit, we distribute t is equal to 0. It will be number 1 simply, right? So number 1 plus 1 and number 1 plus 1 will remain square root of 2, square root of 2 minus 1, square root of 2 plus 1. And this term, okay, 2 and 2 will cancel each other. We're going to have number 3, 2 and 2, just 3 plus 1 and 3 plus 1. Yes, of course. It will be number 3, right? 3 plus 1 will be 4. Square root of 4 will be number 2. So we have number 2 here and number 2 here too. And this one will be simple, right? It's only square root of 2, right? Square root of 2, we have square root of 2 here. And what else? We make a computation here, right? 2 minus 1 and 2 plus 1 is going to be 1 by 3. And this one could be, we cannot do anything more. Just after you put it into the calculator, it's going to be 0.9179. Is that the same result from the first method? ใช่คำตอบเดียวกันไหมครับกับวิธีที่ 1คุณจะพบว่าคำตอบเดียวกันครับโอเคไหมคำตอบเดียวกันในวิธีที่ 1 และที่ 2 นะครับ 0.9 1.9 0.9 1.9 เหมือนกัน Okay, now we move to another integration result. The integration of x squared plus or minus a squared. The x will be what? By 2x square root x squared plus minus a2 and 1 by 2 a squared plus imp. And the negative value of x, the absolute value of x plus square root x squared plus minus a squared. Okay, it's quite complicated. And now we consider what is the length of the curve when y is equal to x squared. So let's draw it. You know that this is parabola, right? Let's say you may use whatever from x is minus 2 and from x is equal to 2. Okay, where is that? The curve of y will be like this. Okay, this is y is equal to x squared. It just reaches the y-axis at 0 level. Okay. But they want to know the length here only. They want to find the length of this parabola from x equal minus 2 until x is equal to 2. How could we solve this? Okay, of course. We start from the basic of such kind of problem. Okay. Method 1 is that if you let x be t, y will be t squared, right? But the second method, you know that when you say y is equal to x squared, it means x, your x will be square root of y. It will be the same. Okay. Yeah, once you let x be and let y be t, right? X will be square root of t, this term. Okay. Okay. Please note that the integration starts from -2 to number 2, and this one would be invalid, right? Because square root of 2 will be a real number, positive. number, right? Further, method number 2 is not correct. It's not possible because square root of negative value will be unknown or it's complex number. Okay, let's consider the first method. The first method, let xt be t and yt be t square, t and t square, right? And 0 in the z component. Now it's time to make the differentiation. You substitute ft by this vector and you will see that you distribute the differentiation to each variable, and dt by dt will be number 1, dt t square will be 2t, and differentiation of 0 will be 0. And after that we compute the norm operator. It's the square root of each 3 components, 1 square and 2t square and 0 square, right? And this one will be 4t square plus 1. And another method is that you try to reduce or unify the scaling factor in front of t square. So you divide by 4, you get 1 by 4, and you can throw away 4 inside or outside. The square root is going to remain number 2 in outside, even outside the integration side. And yes, of course, it's going to be t square plus 1 by 4, and you know 1 by 4 is actually the square. Okay, 1 by 4 is only square of 1 by 2. So now it's time to make the integration, and from what we know previously is the identity, right? Yeah, we know theข้อนี้ยากนะครับโอเคไหมผมเลือกข้อยากมาทำให้คุณดูครับโอเค here x square plus and or minus a square will be like this, right? And the result will be 1 by 2x, okay, 1 by 2t, and x square t square plus a square is 1 by 2 square, right? A is 1 by 2. So wherever we find a, we will let it be 1 by 2. Wherever, no, not anymore. Okay, when we use the result in equation 19, this one, the formula here from equation 19, we could get the result like this. Oh, internet problem, right? Test 1 2 3. อินเทอร์เน็ตหลุดนะครับอินเทอร์เน็ตหลุดนะครับมาก่อนอีกแล้วนะครับชอบแจ็คพอตนะครับโอเคนะครับชอบแจ็คพอตนะครับอยู่ดีๆอินเทอร์เน็ตก็หลุดนะครับไม่มีใครแจ้งผมนะครับโอเคแชร์หน้าจอต่อนะครับอยู่ดีก็หลุดไปเฉยเลยนะครับ Okay, once we use the formula in equation 19, okay, here we will have definite integral, right? We distribute, we substitute t from negative 2 to t equal 2. Okay, integration. This is the result, okay, from equation 19. And here is the step for substitution. Okay, once we substitute t from negative 2 to number 2, we will have the result like this. And of course, you know that square root of 4 plus 1 by 4 is square root 17 by 2, right? So the arc length will be this term, yeah, okay, square root 7, 2 square, this is 4, right? Yeah, okay, this is number 4, and you have 1 by 2, so it's gonna be 2 square root 17, and this term, it's 1 by 4, right? 1 by 4, and we combine this term together. The negative term will be the denominator, and we have it here as the denominator. And this one is 1 by 2 square root 17. And we change the order a little bit to get 1 by 2 square root 17 stay in the front. This one is greater than number 2, right? So we will leave it in front, and negative 2 will stay at the rear part. Okay, once we have these, we multiply it by the conjugate term, okay, which is times 17 plus 2 divided by square root 17. No, yeah, square root 17 plus 2 too. Okay, you distribute this term to this one to this one here, and yeah, now we have the multiplication, right? And for this one, it's going to be the square of the first term and square of the second term added together, right? No, because it's not complex number, it's going to be negative. Okay, it's negative. The first term square and the second one term is square too. Okay, okay, at this step, we have to multiply the whole term by number 2, okay, above and below. So number 2 will be changed to number 4. This one will be changed to number 4, and we multiply it by using the complex conjugate. Okay, but it's not this term. It's square root 7 plus number 2. แต่แป๊บนึงครับอินเทอร์เน็ตผม Okay. Yes. Right, you substitute. You're gonna have 2 square root 7, right? In yeah, we just have the square root of the first term at the power to the square of the first term and the square of the second term, which is number 4, and you just multiply these two factors, and you get something like this: 17 square plus 2 square root 17 times 4 and 4 square. And after that, it's going to be the first term square, square root 7 square, and last term, second term square. We have square root of 17 is 17, right, with the power of 2. And 4 square will be 16, right? This one will be 17, okay, and nothing, right? 4 and 2 will be number 8. And 4 square will be 16. And after that, you combine it together. 17 and 16 will be 33, and this is 8 times square root 17. We don't have numerator a denominator anymore because this is number 1. So leave it inside the root the natural logarithm, and the first term is 2 square root 17, and you leave it into the calculator, you're going to have 9.2935675 like this. Okay, now everything about arc length has been completely shown to you, and we will arrive at the most difficult topic in this chapter, which is the limit of the real value function of two variables. Okay, the way to solve the limit is unpredictable. I would say we cannot have a single way to solve the limit. Okay, let's see what happens. The best way to understand the limit of the real value function of two variables is that we consider the actual problem. For example, if you want to find the limit of x times y, if you want to find the limit of x times y divided by x squared plus y squared, okay, what you could do is that, for example, the limit to coordinate 1, 2, okay, when x is equal to x will reach number 1, y will reach number 2. Okay, what is that? A simple way is that you just substitute, okay, 1 and 2, 1, 2 into this one, 1 and 2 into this one, 1 square plus 2 square. This is number 2 and 2 by 5. And yes, let the function be f x y and x squared plus y squared. And once we substitute the function by x as number 1, y as number 2, we're going to have 2 by 5, 2. So both limit and the actual function will give you the same number. So we conclude that the limit of this function will be 2 by 5 or 0.4. Okay, and yes. Now we consider the limit of the same thing, the same function, but not from 1, 2 to 0, 0. Okay, and let's see what happens. You know that the limit could provide you many solutions. The most simple way, the simplest way is that you can find the limit easily. The middle way is that the limit is diverged. We could not find the limit at all. Okay, and the hardest way to find a solution in the problem of limit is that you have to use fantasy technique. Okay, for x and y to reach 0, 0 of this function, how could we do that? You just simply substitute 0 and 0 for x and y into this term, okay, and see what happens. You could see that if you substitute x as 0, y as 0, x as 0, y as 0, you get 0 by 0, which is an intermediate form, okay? It's not the actual number 0 by 0, okay? It's not understandable number. So we cannot use the simple method. We have to find another alternate method. Let's say if we along the plane x equal to 0, and we're gonna find a limit. And once we substitute x as 0, we're gonna have 0 by y squared, and it's actually 0. So we don't take the limit to y to 0 at all, and the result will be 0. And along the y plane, along the y equal to 0 plane, we substitute y by 0. You could see that y is equal to 0, y is equal to 0 both. and you would have 0 by x squared. It's also 0. And along the plane y equal to x, when y is equal to x, okay, you substitute y as x and let x be 0. Okay, let x tend to be 0. You could see that this is x squared, this is 2x squared, right? And it's actually 1 by 2. There is no variable x at all, so we have 1 by 2. And once we have determined the limit 3 times from 3 different planes, plane x equal to 0, y equal to 0, and y equal to x, and the outcome or the results are not the same. Okay, this will be the same as this one, 0 and 0, but it's not the same value as 1 by 2 for this plane. So we will conclude that once the limit give 2 different numbers, we're gonna say the limit here does not exist. Okay, it's diverged, it doesn't converge. Okay, now we move to the next problem. Okay, it's quite similar to each other. Let's compare. Okay, here you have in the previous problem we have xy by x squared plus y squared, but this one is xy squared and x squared plus y quadruple. Okay, with the power of 4 of y less to 4. Okay, y to 4, but this is y to 2 only, and y, and here is y squared. Okay, it's the limit will be the same. Xy will reach 0. We will solve this one. Okay, and in the first step is that you have to substitute x and y to be 0 according to the destination of the limit, and you would find that 0 times 0 squared and 0 squared plus 0 with the power of 4, you get 0 by 0 again. This is intermediate form. We cannot find the limit of this one easily once we have made the test here. The first step is that let x be 0 and see what happens. When x is 0, we're going to have 0 times y squared and 0 squared plus 4 squared, right? It's going to be 0 by y with the power of 4, and it actually 0, okay, before we take the limit. And along the y, the plane y equal to 0, we can determine the limit. Let y be 0, right? When y is 0, y squared, 0 squared, and 0 with the power of 4, you get 0 above, and 0 divided by x squared, you will get 0 here. And for any plane y is equal to mx, right? When y is a scaling value of x, we substitute y by mx. Okay, this is the location of y, location of y. We get mx and mx with the power of 4. Or simply speaking, it's going to be the m squared, right? I'm still with ผิดนะครับผิดนะผิดตรงนี้ต้องเป็น m ยก2ผิดนะครับโอ้สอนมาตั้งหลายปี m square and m square 2นี่นะครับลืมนะครับ okay and m square there, right? X m square x to 3 and x square m to 4 x to 4, right? And after that we divide the whole equation by x square, right? This is gonna remain number 1, and it will be remain x and x by 2 x square. It will be x to now x square, and it's time to take the limit when x is equal to 0. When x is 0, we have 0 here, 0 by 1, so it's 0, right? And yeah, 0, 0, and let's see what is the result when x is equal to m times y squared. Okay, x is a function of y but y squared, and we're going to substitute x by my squared, my squared and y squared, my squared, right? So it's going to remain m with times y to 4. This is m squared y to 4, y to 4. We have 3 terms of y to 4. We divide the whole equation and the whole ratio by y4, right? Y to 4. So it's y to 4 will disappear. We have m and m squared plus 1. We get m divided by m squared plus 1. Once the limit start to have different value like this, we will conclude that the limit, this one, doesn't exist. Okay, it has no limit, it's diverged. Okay, because it gives us different value of the limit in whatever direction. Okay, the limit will exit when for whatever direction we reach the same value, and that's the limit. But once we have tried 4 planes. Okay, the first plane, the second plane, the third plane, and the fourth plane. The fourth plane gives us a different value of the limit, so it doesn't reach the same value. We conclude that this limit doesn't exist. Now let's consider the fourth problem about limits. When y to 4 divided by x squared and y squared. This one is quite difficult, okay, and I would not take it as the exam because I don't think that you're gonna be able to solve this. Okay, anyway, let's see. The way to solve this is totally different from the previous problem. In the previous problem, we test the limit from the plane, right? From different planes, and once it starts to give us a different value, then we conclude that the limit doesn't exist or it's diverged. But this problem is different. We consider the numerator y to 4. You know that y to 4 is the absolute y with the power of 4, and the absolute value is the square root of the y square, right? And for whatever value of x, if we add x squared to inside the square root to y squared, it should be greater than this single term, right? Even x is negative, the square root of this one should be greater than this one. And of course, this is the square root of x squared plus y squared with the same the power of 4. And the square root is actually the power of 1 by 2, right? And once you distribute 4 to 1 by 2, it's going to remain number 2. So we have y4 is greater than y24 is less than or equal to x squared plus y squared with the power of 2. And if divide x squared y squared on both sides of this equation, if we divide it, we're going to have y24 divided by x squared y squared, okay, this term. And we divide this one by x squared y squared. We have this, right? Because this is the power of 2 of the denominator, and we have x squared plus y squared, simply. Okay, now if we take the limit, because all of these will be positive, right? If we take the limit, we're going to have here the absolute value of this term is less than the absolute of this term. And it's actually positive, so whether we have the absolute value or not, we will get positive value. And we take the limit of 36 to 0 and 0 on both sides. So we're going to have take the limit, right? It's going to be 0 and 0, yeah. 0 square plus 0 square is 0, right? So the limit of this one is less than 0, but please note that we don't have the absolute value at all. Suppose the limit fx and y and gxy exists. If the absolute value of any function of two variables minus a certain value is less than a function for all x and y, and if the limit of gx on the right hand side is equal to 0 for whatever point, whatever coordinate, we will conclude that limit of this function is equal to L. And what is that? It means if we write down this one again, it is y to 4 minus 0, right, equal to 0. So y to 4 divided by x squared plus y squared is fxy, and if we have minus 0 here, gx is x squared y squared, we can conclude that the limit of this one is equal to 0. All right. Okay, it might be a little bit difficult, but we need to use this property, the property of the limit here. We have the limit when x and y to 0, 0 of the absolute value y to 4 divided by x squared plus y squared minus 0 and is less than or equal to that function gxy, and is less than x squared y squared. So sorry for that. We don't have to take the limit at all. It's x squared plus y squared, right? And you could see that this is f xy, and here is d xy, and here is L, the limit value, which is equal to 0. And yes, of course, you know that limit x y to 0, 0 of the xy, which is the limit x y to 0, 0 of x squared plus y squared tends to 0, right? We satisfy this condition, and we conclude that limit of this term is equal to L, which is 0. So we can conclude it like this. Okay, so we conclude that the limit of this one is equal to 0. Okay, let's consider this one. Find the limit of 3x squared times y divided by x squared plus y squared, x to 0 and y to 0. Okay, at the end of this one นะครับให้คุณลองแก้ปัญหานี้ดูนะครับในชั่วโมงนี้นะครับโอเคไหมแล้วดูว่าลิมิตออกมาได้เท่าไหร่ผมก็ไม่รู้เหมือนกันครับโอเคไหมลืมไปแล้วนะครับสอนไปก็ลืมไปครับ 3x squared and y and divided by x squared and y squared. What is the limit of this? ทุกคนลองทำที่ตัวเองนะครับแล้วพิมพ์บอกผมว่าได้คำตอบเท่าไหร่ครับ all right. What is the result of this one 3x squared times y and x squared plus y squared ได้เท่าไหร่กันครับลองทำนะครับทุกคนลองทำแล้วก็ผมพาทำให้ดู4ข้อแล้วอันนี้ตอบเท่าไหร่นะครับคิดว่าตอบเท่าไหร่ดีนะครับมีดูกันบ้างหรือเปล่ามีอยู่6คนที่5คนลบผมไปด้วยนะ5คนที่Steam Lab นะที่เป็นกล้องถ่ายไปที่หน้าจอ iPad ครับแล้วก็ที่อื่นไม่มีใครดูครับอยู่ที่ Zoom กี่คนอยู่ที่ Zoom มี2คนเข้ามาพิมพ์ชื่อแล้วก็ออกไปนะครับแต่ว่าพิมพ์ชื่อมานี่มี4คนครับ alright ก็จะเหลืออยู่7คนครับห้องเรียนนี้ตอนนี้เหลือ7คนครับโอเคโจทย์นี้นะครับโจทย์นี้หาลิมิตได้เท่าไหร่ครับระหว่างนี้เดี๋ยวผมเก็บไฟล์ที่เขาส่งมาให้ที่รอคุณนะครับว่าลิมิตได้เท่าไหร่เข้ามา6คนแล้วนะครับ The limit does not exist นะครับชัยกิจยิ่งสวัสดิ์นะครับที่ซูมว่าไงโอ้ผมหลุดเนาะอินเทอร์เน็ตหลุดก็เลยหายไปเลยโอเคชัยกิจ said the limit doesn't exist see what he said okay no in the Streamlab channel right in the Streamlab channel no Streamlab channel here okay ชัยกิจยิ่งสวัสดิ์นะครับ say the limit doesn't exist okay I don't know how why the limit doesn't exist anyone else who confirm that the limit doesn't exist is there anyone else who could confirm that the limit really doesn't exist I don't know how to solve this here we have Wolfram Okay, let's see. 3 times x squared times y divided by x squared plus y squared, right? Approach 0, y to 0 too. Okay, from whatever direction. Okay, to left and right. Okay, compute. Okay. Okay, step by step, right? To 0 minus and 0 plus, we get 0 all the time. Okay, this is the step, right? First we substitute x to be 0 first, right? Oh, no. Y to be 0 first. Y to be 0. Okay, and we have 0 by x, or 0 here by x squared, so it's gonna be 0, right? And the 0 plus, we take the limit of y to be 0, and you can see 0 by x squared is also 0. But it doesn't mean that the limit remains 0, right? We have to check whether when cross plane. Anyone else มีคนอื่นทำไหมครับคนอื่นทำไหม plane x equal to 0, what happened? It's gonna be limit y to 0, 3 0 square times y divided by 0 square plus y square. So you have limit y, limit y to 0 of 0 by y square, so it's already 0. Plane y equal to 0, what happens? We're gonna have limit x to 0 and 3x square, and this is 0 divided by x square plus 0 square, and is equal to limit of x to 0 of 0 by x square, so it's equal to 0. Okay, it seems to be 0 because we have both limit solution as 0, but it's not the case. Let's go further. Oh, sorry. Let's consider the plane y equal to mx. What happened? Limit of x and y to 0, comma 0, right? It's gonna be 3x squared n mx divided by x squared plus mx squared, and that's equal to 3 that's equal to 3mx with the power of 3 n plus m square plus 1 times x square, right? And what is that? And that's it's equal to limit limit of once we substitute y, so we don't have to write down x and y anymore, because y is it's going to be x to 0, so limit this one will be to 0, right? It's 3mx divided by m square plus 1, right? So it's 0. And what else? Let's consider another plane, like when mx square, what kind of plane they consider in this one? Oh, this arc length y equal to x, and mx x my square, x equal to my square. When x is equal to my square, what is that? No, this one is x square, right? X square, x to 4, x to 4. Sorry. Let's consider this one first. When y is mx square, limit x to 0. What is that? And 3. Oh. We consider the plane y is equal to mx square. What is that? It will be limit x to 0 and 3x square, y is mx square divided by x square plus y. Oh, this is mx square power 2, and it's going to be limit x to 0, and this one will be 3m x มือไม่ไปตามปากครับ 3m x to 4 divided by it's gonna be x square plus m square and x to 4, right? And it's equal to limit x to 0 is equal to limit x to 0, and we divide the whole term by x square, right? So it's going to be 3m square by number 1 plus m square x square. We still have x square above, yes, and now it's time to take the limit. It's gonna be 0 by 1, and it's equal to 0. Can you use y equal to 3x and x equal to 3y โอเคชัยกิจพิมพ์มาโอ้ผมไม่เห็นขออภัยด้วยโอเค x in terms of y right เหมือนกันนะครับ y mx กับ x my เหมือนกันนะครับไม่น่าต่างกันโอเคแต่ว่าเพื่อความกระจ่างเดี๋ยวผมทำให้ดูโอเค we consider the planeเอาอะไรครับ3x ไม่ต้องนะ 3x เพราะว่าถ้าคุณแทน m เป็นเลข3มันก็ 3x ไปแล้วสำหรับ x my แล้วกันโอเค x is equal to my what is that we're gonna have limit y to 0 and 3x square okay x square will be my square times y divided by x square plus y square and it's going to be limit y to 0 and 3m square y power 3 divided by sorry for that we have to substitute x here x is my square right so it's gonna be m square plus 1 and y square so you can cancel y square okay in the numerator and denominator right it's gonna be limit y to 0 and 3m square y divided by m square plus 1 and then you will get of course 3m square and 0 divided by m square plus 1 it's equal to 0 and ชัยกิจนะครับชัยกิจไม่ทราบว่า divert ยังไงบอกว่า limit doesn't exist ดูแล้วมันจะลงศูนย์หมดเลยครับลงศูนย์หมดเลยไม่ทราบว่าชัยกิจใช้เพลนอะไรx เท่ากับ 3y บอกไปแล้วว่าเหมือนกันนะครับโอเคไหมแทน m เป็นเลข3ก็ไม่ส่งผล9ไม่ส่งผลโอเคไหมใช้คือใช้อันไหนครับถึงบอกว่ามัน divert sorry I miscalculated โอเคนะครับโอเคyes the answer seems to be 0 and if you want to use this relation this rule we may try I will try it for you what is that x square y right how the absolute value of this one right how is that right ใช่ไหมไม่น่าใช่ no I don't think we and at the moment I could not find a technique to use this technique okay this condition ตอนนี้ยังไม่รู้ว่าถ้าคิดแบบ ใช้เงื่อนไขนี้จะคิดยังไงนะครับเพราะว่าตื่นเต้นไม่ได้เตรียมมาครับ anyway once we try many ways we can conclude that so the limit of this one limit of 3x squared y divided by x squared plus y squared will be 0. Okay, and that's it. And according to the result from the website here, yeah, we get also 0 for both sides. 0. Okay, left side or right side we get 0, so the limit will remain 0. Let's move to limit. You can see that the limit problem has no actual solution, right? They have different methods to solve, and it's quite difficult. And now we consider the partial derivative. If we have a function that depends on x and y, you could see that everything here depends on both variables x and y. All right. In yes, the domain x and y is the domain. Okay, it's the domain, and it maps to the outcome, the output. F, x, and y are related to 1 by 1. This is the real value function, and the domain lies in, for example, 2 times 1, because x and y could be a real value numbers, right? Yes, it could be a real value number. Sorry, ผมขยับเมาส์ผิด yes, the next one is that if the point A and B be the point in the domain D, okay, let's consider the point that we want to find the derivative, okay, which is denoted by A comma B. Please note that this is the function of two variables. We have to specify two variables, 2 points, okay, 2 values for both variable x and variable y. Okay, that's why we have A comma B. It's not like a single derivative, single variable derivative. You just find derivative at any point x equal to A, x equal to wherever you want. But here, for the function of two variables, you have to say two values, A comma B, A for x and B for y. And we need to introduce this operator. Okay, it looks like, I don't know, it's a special symbol. It's known as curl. Okay, curl or partial or del. Sometimes they call curl, sometimes they call del. Okay, whatever name they use, it's a partial differentiation operator. And we're gonna see ขอโทษแอร์เย็นครับ Okay. Now we arrive at the definition of the partial differentiation. Right? If we differentiate this function with respect to x, the first variable x, at the point a comma b, we would have partial derivative of this location. Okay, we substitute y as b. Okay, and we want to see the difference with respect to x, right? It's going to be limit h to 0 and 1 by h. You know, h is a differential amount. It's a differential amount ไม่เป็นไรนะครับใช้คิด นะครับขอบคุณมากครับที่ตอบนะครับ thank you. When h is very very tiny amount and it tends to be 0 and a, okay, at point a is increased by the little amount of h and the difference between that function to the function at exactly at point a and b, and the partial derivative of x y with respect to y will be defined in the same way. With respect to x, we need to substitute the value of y by b, but with respect to the partial derivative with respect to y, we need to substitute x by a. That's why we have here. And the difference here will be made with respect to the variable y, which is b plus the different amount, okay, which is very tiny, and minus the point of that function, minus the function at that point exactly, and just let the difference be divided by the tiny amount, and we take the limit of the tiny amount to 0, and yeah, that's the definition. And okay, don't worry about that. That those are only the definition, but in practice, if you want to find the partial derivative, we could do in the following. Let's consider the first example about the partial derivative. We use the curl or the del operator here. Okay, if you have a single variable like fx equal x squared, yeah, if when you want to say you want to find the derivative, you should use d by dx of fx, okay, and dx by x, and you have 2x. It's all right, it's correct, okay, but you cannot say it's you cannot say it's curl by curl x of fx, and it's going to be curl x squared by curl x equal to x. No, you are not allowed to use this. Don't do that, okay? Don't do that. Use d when you have a single variable, and if you have two variables like this, and if you have two variables, if you have two variables in the function, okay, if you have two variables, if you have two variables, okay, if you have two variables like this, like for example, if fx y equal to 3x squared plus 2y 4, and you cannot say you want to find d by dx of fx y, okay, it's incorrect. You are not allowed to do that, okay? You cannot say it by using d by dx. You have to say it by using the curl operator only, okay? It's like yeah, so you can do it further. It's like here 3 x squared and x plus and 2 curl by curl x of y to 4, okay, and this 3 to x in, oh, this is 2 and 0, and you get 6x, okay, and that's it. It's fine. You cannot use d by dx when you have two variables x and y for the function. If you have more than two variables, you need to use the curl operator. It's like the English grammar. You say red. It's wrong. Okay, this one is wrong because we have only a single car. The correct one is both cars are pink. For example, this one is correct. Okay, this one is alright. It's correct, but this one is grammatically incorrect. Okay, because you cannot use R for a single object. All right, you understand that? Yeah, in mathematics, we have also grammar. You cannot use d by dx for the function with two variables. You are not allowed to do that. It's wrong in mathematics. You have to use curl or del by dx only when you have more than one variable. If you have f, x, y, and z, you have to use curl by curl x2. Okay, yeah, something like this. Okay, it's grammar. It's the rule in writing. Okay, พอเข้าใจนะครับ and let's go further. Okay, let's consider this one. Sine x y squared divided by x squared plus 1. ตรงนี้มีออกข้อสอบด้วยนะครับตอนกลางภาคครับPartial dip. Okay, what is that? Yeah. This is the objective function, and we differentiate it with respect to x and with respect to y, right? Let's consider the one that differentiate the function with respect to the first variable x, and of course differentiation of the ratio, right? Differentiation of the ratio with respect to x, both numerator and denominator contain x variable, right? Variable x. So we are going to be we're going to use this relation, right? The differentiation of the ratio d by dx of ux and vx is gonna be, oh, sorry for that, I don't manage the space. Okay, we're gonna use this relation d by dx of ux by vx, right? It's gonna be ux and d by dx of vx and vx d, oh, we don't have enough space. I'm sorry for that. d by dx of ux divided by vx will be ux and d by dx of vx, right, minus vx and d by dx of ux and divided by v square x, okay, the denominator square. And we're going to use this rule, right? I think you have ever seen this result before, right? In the basic mathematics subject or something like that. And for us, we have also ux here, which is sine xy square. And vx, our vx is equal to x squared plus 1. This is ux, this is vx. So ux, oh, I'm sorry for that. I'm stupid. Vx first, I'm stupid. Okay, v and u, okay, and yes, yeah, v first, v here, okay, this is x squared plus 1, and differentiation of the numerator, which is this one, right, differentiation with respect to x, and negative, right, minus, and then ux is this term, right, sine xy square, so we follow that. And the next one is differentiation with respect to x of vx, so vx is right here, which is x squared plus 1, okay. Please note that I use d by dx because these are both functions depend on only x variable, only variable x. But this one depend on, this function depends on x and y. We have to use del or curl operator. Okay, yeah, it's gonna be del by the x, right, and minus sine x squared, right, d by the x squared plus 1. Now it's time to differentiate this one. Because the differentiate of sine function will be cosine function. We have cosine function, and we need to differentiate the argument inside the sine function too, right? Okay, we have something here, right? Differentiation of this term with respect to x times y square, and differentiation of these terms with respect to x, right? We're gonna have 2x and 0, okay, because this doesn't have variable x at all, it's gonna remain 0. And differentiation of this term y square is not related, right? It's irrelevant. We will move y square outside the parentheses. Differentiation of x will remain number 1, so we have y square only here. Cosine square is forward, okay, and 2x will stay in front of sine xy square. And this term, the numerator will be the vx square, right? X square plus 1 square. And that's the result of the derivative, partial derivative with respect to x. What about the partial derivative with respect to y? Okay, yeah, we follow in the same way, but note that this term, the denominator, doesn't have variable y at all, right? You don't need to use this complicated formula. You just simply use this formula instead. D by dx of, sorry, you just use solely a ux will be a, will be a, and d by dx of ux, okay, when a is a constant, no. When a is a constant, if you have ux divided by a, you just move 1 by a in front of that, and you have you will have d by dx of ux. All right, because a is a constant and a doesn't depend on x, we could move a, which is the denominator portion, out of the differentiation operator. It's going to be 1 by a, and later on we will start to differentiate ux with respect to x, and it's the same here. If you want to differentiate this ratio with respect to y, please note that x squared plus 1 doesn't have variable y at all, so it looks like the constant a for this formula. So we will move x squared plus 1, which stay at the denominator, out of the differentiation here. It's a constant. And now it's time to start the derivative with respect to y. And of course, we know that differentiation of psi will be cosine. So we have cosine, and the next one is that we have to differentiate the argument inside the sine function, which is x y squared. And after that, you can see that x, we make the differentiation with respect to y, right? X is not related to y. X is a different value of variable compared to y. X will be moved out of the differentiation operator. X is going to remain here, staying here. Okay, and now we have differentiation of y squared with respect to y, and it's equal to 2y. And after that, we move 2y to be together with x, so 2xy and cosine xy squared. That's the result for the first problem about the partial derivative. Okay, in higher order partial derivative, is the following. Once you have differentiation with respect to x, you start from this one, and if you differentiate with respect to x again, it's going to be differentiation with respect to x squared, and if you differentiate it with respect to y, it's going to be differentiated to x first and differentiate to y, which means you do the differentiation 2 times. Okay, x first and then x first and then y. And if you start from differentiation with respect to y, if you differentiate with respect to y again, you're gonna get something like this. Okay, differentiate with respect to y squared. And if you differentiate this one with respect to x, it's gonna be differentiated to y first and then x later. Okay, y first and then x later, and so on. Okay, and furthermore, and let's consider differentiate to x squared and y squared, x first and y later, y first and then x later, for the function exponential x squared and y plus xy to 3. There is no solution, and we are gonna finish this chapter. Okay, let's do this. There is no solution. Please write down the answer. What do you think for both for four quantities of derivatives here? Okay, four derivatives. ลองทำดูนะครับถ้ามีฟังก์ชันแบบนี้ดิฟเทียบ x กำลังสองได้อะไรดิฟเทียบ y กำลังสองดิฟเทียบ x ก่อนดิฟเทียบ y ทีหลังดิฟเทียบ y ก่อนดิฟเทียบ x ทีหลังได้อย่างไรครับลองทำดูครับ Okay, we still have 48 minutes. And do you want to start the chapter 6 immediately? ต้องการถ้าจบหน้านี้แล้วนะเดี๋ยวผมเฉลยให้นะครับแต่ผมเฉลยให้คุณต้องการขึ้นบทที่6เลยไหมผมมีสไลด์อยู่แล้วแค่ไม่ได้เปลี่ยนวันที่นะครับหรือว่าจะไปครั้งหน้านะครับแล้วแต่นะตัดสินใจมานะครับโอเค differentiation for derivatives here นะมี5คน ที่ Streamlab นะครับที่ดูถ่ายทอดจากเอากล้องถ่าย iPad นะครับแล้วก็ที่ช่อง Zoom ไม่มีใครดูนะครับ and for the people in Zoom we have 2 students only here, right? Okay, only 2 students. Okay, the second derivative.นะครับรอคำตอบจากคุณนะครับ I'm waiting for the results from you, okay, the solutions from you. next week นะครับชัยกิจบอก next week นะครับบทที่6นะโอเคผมก็จะได้ไม่ส่งบทที่6ให้คุณเลยนะครับโอเค next week รอคำตอบอยู่นะครับคำตอบ I'm waiting for the answer from you for these 4 derivatives, second order derivative. So what are the answers to these 4 derivatives เป็นไงครับคำตอบของเสียนี้นี่ผมเก็บรายชื่อไปแล้วนะครับเหลือซูมที่ยังส่งไม่ได้นะเพราะว่าเครื่องนี้ช้านะเครื่องรุ่นเก่า alright คิดว่าออนกันเฉยๆไม่มีใครทำนะครับชัยกิจว่าไงอันนี้ทำได้ไหมเอ่ย alright once we have fx and y like that we're gonna find first curl by curl x โอ้ตัวใหญ่ไป we're gonna find first curl by curl x of fx and y which is curl by curl x exponential of x squared y right plus curl by curl x of curl by curl x of x y triple right y cubic power of 3 yes of course for the first term you know that it's going to be differentiation of differentiation of x exponential of ux will be exponential of ux and you need to differentiate with respect to ux again right and that's the exponential of x squared and y right and differentiation with respect to x of x squared y right and plus this one here and please note that y with the power of 3 doesn't depend on x right we're going to move it out of the differentiation like this okay we're going to have curl by kx of x like this and of course in the same way y doesn't depend on x we're going to move y out of this one oh I'm stupid exponential of x squared y we're going to move y out of the parentheses that's it means we have y exponential x squared in y in here differentiation of x with respect to x and plus y with the power of 3 curl by curl x of x and of course right here we have y exponential of x squared y and of course here is the result of 2x plus y with the power of 3 and is number 1 right here right so the answer will be 2xy and exponential x squared y plus y with the power of 3 now we need another we need another one with respect to y first right the first order curl by curl y of fx comma y equal to curl by curl y exponential x squared and y plus curl by curl y xy with the power of 3 and of course the first term will be exponential of x squared y in curl by curl y of x squared y closing parenthesis right and for the second term because x doesn't depend on y we're going to move x out of differentiation we have here curl by curl y of y with the power of 3 all right and this term, right, x squared y, and you could see here that x squared doesn't depend on y. We move it out of parentheses. It's gonna be x squared curl by curl y in y, right? And plus x, and of course the result here will be 3y squared, right? So you have 3y squared in right here. You're gonna have x squared in front of that, exponential x squared y, and this number one right here, and plus 3xy squared. Okay, so the final result will be x squared exponential x squared times y plus 3xy squared. All right. Now it's time to consider the second order derivative, right? There are 4 terms. Right, doesn't have the same side. Huh? Why doesn't have the same size? I'm going to use the copy it again. No. Okay, this one. Okay, let's consider first curl by curl x squared of f x y. Please note that once you have the power of 2 at the denominator, you should have always the power of 2 at the numerator too. Okay, so that both will be balanced. Both will have the same order of power. And yeah, we're gonna use the result here, right? What is this? This is the curl by curl x of this thing. Curl by curl x of f x y, right? And what is that? It's actually curl by curl x of anything that we have. What we have is the following. What we have is the following. Okay, what we have is the following. It's 2xy, right? We write down here 2xy exponential x squared y and plus y to the power of 3, right? Something like this. Okay, but before we go to the second order derivative, let's check whether our first order derivative is correct or not. Otherwise, we're going to lose so much time. And the way to do that is the following. We consider derivative calculator. Derivative calculator. Okay, here. Here. All right. Differentiation with respect to x, right? The function is exponential of x2 y n plus x times y with power of 3, right? So let's see let's check whether our result is correct or not. Right. So the result is 2yx e yx squared plus y 3, right? It's correct. And if you want to change it with respect to y, okay, let's check the result here whether it's correct or not with respect to y. Okay, let's check whether it's correct or not. Okay, see. Okay, it turns out now it's equal to x squared e x squared y, x squared e x squared y, and 3xy squared 3y. So it's correct. Okay, our results here are correct. And now it's time to go to the second order derivative, right? With respect to x, all right. With respect to x, so we're gonna have 2y, okay, 2y and curl by curl x and x e with power x then y. The reason why I moved to y out of the differentiation because 2y doesn't depend on variable x, so it's constant. We move it out of the differentiation. And the next thing is the curl by curl x of y with the power of 3. So it's 0, right? The last term is 0. And here we have 2y and of course the differentiation of product, right? And you could know that it's going to be it will be this term, right? In curl by curl x of x squared y and plus exponential of x squared y in curl by okay, no problem. Curl by curl x of x, all right, and that's it. And here the last term is 0. All right. And here we have 2y, right? And this term is going to be x in what is that? It's exponential x squared and y, and we're going to differentiate again, differentiation of differentiation with respect to x in x squared y, right? And plus, right? No. Or simply speaking, we don't write down these parentheses anymore. It's too complicated. We cannot remove these. Exponential x squared y. All right. And plus this term, right? Exponential x squared y and number 1, right? And closing parentheses. We have the common term, which is exponential x squared y. Okay, we move it out of that. We're going to have 2y exponential x squared y. And here inside we have x. And of course, y doesn't depend on x, right? We move y first out of that. Curl by curl x of x squared. And Once we move this term out of the parentheses, this term is going to remain number 1. So this is number 1, right? And the remaining differentiation is only this term, right? Is 2x. So 2y exponential x squared y and x, y, and 2x and plus 1, all right? And finally, we're going to have 2y exponential x squared y and 2x squared y plus 1, all right? And that's it for the first answer, all right? Let's check whether our result is correct or not. Okay, with respect to x, right? And 2 times, right? Twice. Let's check the result. Oh my God. So the answer is the following. It's equal to 2yx oh y. Oh, here. Okay. Okay, it's the same. Okay, if you distribute 2y inside this, you're gonna have 4x squared y squared and plus 2y, right? And yeah, the result here is correct actually, but we move the common terms out of the parentheses. And the next one, right, is the differentiation of x first and then y, right? Okay, we're gonna see what's going on here. Differentiation of y later and x first of x, fx and y, right? So it's gonna be differentiation with respect to y of differentiation with respect to x of fx and y, all right? And as we know, we have got already the result for differentiation with respect to x, right, which is this quantity. So we're gonna write down here curve by curve y, right, in 2xy ex squared y and plus y to the power of 3, right? That's the previous result. And we are going to distribute the differentiation operator to both terms, right? And you can see that 2x doesn't depend on y, right? We move it out of the differentiation. So we have 2x and curve by curve y of y. Oh. Curve y and y times ex squared y. And plus curve by curve y with the power of 3, all right? And yes, of course, you have 2x first, and after that, you're gonna have the differentiation of the product, right? 2 terms here. Okay, is y and curve by curve y of ex squared y, right? And plus EX squared Y in curl by curl Y of Y, right? And for this term, right, we're gonna have 3y squared, right? And that's it. And right here we have 2x, right, in y, right? Okay. We have y, and once we differentiate this term, right, we're gonna have exponential x squared y and the curl by curl y of x squared y. All right, and here we have e of x squared y and number 1 in plus 3y squared, right? Yes, this term. All right, and you have 2x and yeah, the common term, we don't have common term there. X squared y is not a common term anymore. Here we have y, right? Y e x squared y, and of course we're gonna move the constant, which is x squared here. X squared doesn't depend on y. We move it out of the differentiation. It's gonna be x squared in curl by curl y times y, right? And plus ex squared y and plus 3y squared, right? And yes, of course, if you go further, it's gonna be 2x in open parentheses in yes, of course, x squared y, right? X squared y and ex squared y in times number 1, right? Plus ex squared y plus 3y squared, right? So the final answer will be 2x, right, in x squared y e x squared y without number 1, right, is constant, and e x squared y and plus 3y squared. Okay, 3y squared. And that's it for the derivative with respect to x first and y first, x first and y later. Okay, let's check whether our result is correct or not. Where is that? Oh, here. Okay, we are gonna differentiate the result here. Cross term, right? Not sure. No. Okay, no problem. Oh, what happened? I didn't share screen. My God. What happened? Oh, it doesn't exist. It's not shown. All right. Fine up. Primary. All right. In okay. Differentiate with respect to y, right? In 2xy e with the power of x squared in y, right? In plus y plus y to the power of 3, right? With respect to y, right? With respect to y, loss. Okay, it turns to be, oh, I'm wrong. My God, I'm wrong. 2x should cover, these parentheses should cover only this term. Okay, should cover only this. It should cover only this. Here. All right. All right, right there. It should cover only here. Okay, and the result is 2x. Okay, 2x to 3, right? 2x with the power of 3 and y, and 2x in front of it. We move. Okay, we have to move ex squared y out of that, right? And yes, x and ex squared y and x squared y plus 1, and yeah, and closing parentheses like this, and that's the result. All right, and the next one will be the cross, right? The cross derivative, right? Curl by curl x, right, square, curl by curl y, fxy, right? And it's going to be here, right? No, yellow. And yep, curl by curl x of curl by curl y, right? Of f x y in closing parentheses. In yes, it's going to be curl by curl x of the result from curl by curl y, right? Here, curl by curl y result is the following. Here is the 2y. Oh, with respect to x, right? Okay, all right, it's fine. 2y exponential x squared y and 2x squared y plus 1, right? And closing parentheses, and we're gonna do that later. Yes, of course. Please note that 2y doesn't depend on x. We're gonna move it out of the parentheses to y, and we arrive at right now curl by curl x ex squared y and 2x squared y plus 1, right? Closing parenthesis like that. And differentiation of two terms like this, okay, again, once again, we could have the result like this, exponential x squared y and curl by curl x of 2x squared y plus 1 and closing parenthesis and plus, okay, plus the last term first, right? The second term first, 2x squared y, 2x squared y plus 1 and curl by curl x of ex squared y, right? And closing parenthesis like that. And we're gonna have the result like this. There's of course 2y, the first term, and we would have ex squared y, and because 2y doesn't depend on x, we're gonna move out of parentheses, and here we have curl by curl x and x squared, right? And the result for the second term is 0, right? So we don't have to write it anymore, right? It's 0. And for this term, yeah, you have plus, right? 2x squared y plus 1, right? And curl by curl x of course, the first term will be ex squared y, right? In curl by curl x of x squared y, right? And closing parenthesis. And right now we have 2y open parenthesis ex squared y, 2y, and here 2y and here 2x, all right, and plus 2x squared y and plus 1 and exponential x squared y. And of course this term y doesn't depend on x, right? So we're gonna move out of the parentheses. We're gonna have curl by curl x of x squared again, right? And closing parentheses. And here we have 2y, right? Ex squared y and 4xy, right? Plus 2x squared y plus 1, right? Yes. And we have y ex squared y and 2x, right? And closing parenthesis. And after that, we have 2y ex squared y. Oh, sorry. And 4xy ex squared y, right? In yes, of course we have 2xy, right? And 2x squared y plus 1, 2x squared y plus 1, and ex squared y and closing parenthesis. And we move the common term, which is 2xy and ex squared y out of the parentheses. We're gonna have 2xy, right? It's gonna be 4xy squared ex squared y. And after we move to xy, right, it's gonna be number 2 here. And we have plus 2x squared y. Oh, 2x squared y and plus 1, right? Yes, and finally, it's going to be 4xy square ex square y and 2x square y plus number 3. Okay, and that's it. So let's check the result with respect to x, right? And where is that? Oh no. Yeah, right. Yeah, we start from, oh, what happened? The keyboard doesn't work again. It's no problem. Oh no. Okay, we and okay, remove that, and with respect to y, right? Respect to y is this one. X with the power of 2 and e with x to y, ex to y, and plus 3x y with the power of 2, right? And we differentiate it with respect to y, right? Right, with respect to y. See what happened. The result is, oh, y is quite simple like that. So y and then x. What? Oh, I took the wrong input here. Is incorrect. My God, it's stupid. It's wrong here. I took the wrong one, and that's why it's so complicated. This is wrong. Okay. ผิดนะครับอันนี้ผิด so นะครับมองไม่ดีใส่ค่าตรงนี้ผิดนะครับ so it's wrong, right? And that's why I feel that it's quite difficult, because this is the third differentiation, actually third order differentiation. Stupid. Right. No, this one here, x square, right? X square x square y plus 3xy square. Okay, this is the correct input, and let's see what happened. Just of course the first term will be x square d by curve x of ex square y and plus ex squared y curl by curl x of x squared, right? And for the last term, 3y squared is a constant, so we move 3y squared curl by curl x of x, right? And here you would have x squared ex squared y and curl by curl x of x squared y, right? And here you have ex squared y times 2x, right? And yes, of course, this is the plus term, right? Plus 3y squared and number 1, right? And it's going to be x squared ex squared y, and we move y out of that, and we're going to have curl by curl x of x squared. And here we have 2x ex squared y and plus 3 to the 3y squared. And after that, it's going to be 2x, right? X squared y ex squared y and 2x and plus 2x ex squared y and plus 3y squared. And here we have 2x with the power of 3 and y ex squared y. Oh no, because there is a common term 2x, right? And we move first to x ex squared y and x squared y plus 1, right? And plus 3y squared, right? And that's it for the whole result. Let's check whether it's correct or not. Okay, it's y. Input is x squared ex squared y plus 3xy squared. The result is x4 6xy y. Yeah. No. This is done with respect to x. I'm sorry for that. Okay, with respect to x, it's gonna be something like this. Okay, we have the common term 2x, right? 2x out of this and exy squared, 3y squared as the last term, right? 2x exy squared, and it's gonna be x squared y, right? Plus 1. Okay, it's correct for this term. Let's consider the last one. We are 10 minutes late. Curl by curl y squared, right? Curl y squared of f x y, right? This is gonna be curl by curl y of curl by curl y of fxy, right? Fxy closing parenthesis, and that's the result. Curl by curl y, and of course is x squared ex squared y. x square e x square y x square e x square y plus 3xy square plus 3x xy square 3xy square, and we go ahead with that. Okay, it's better to move here to the left. Okay, with respect to y, right? So it's gonna be x square and curl by curl y of ex square y closing and plus 3x curl by curl y next to y square, right? Right, curl by curl y of y square with respect to y, and of course we're gonna have right here x square and is gonna be exponential x square y curl by curl y of x square y, and this term 3x and 2y, right? We go further, it will be x square e x square y in of course x square out of the parentheses curl by curl y of y, and here we have 6xy, and if you go further it's going to be, oh sorry, I forget to mention this is okay, I have already mentioned this is x with the power 4 and ex square y, and here is number 1 plus 6xy, and finally we are going to have x to 4 ex square y and plus 6xy. All right, let's check the result with respect to y. Respect to y, right? Respect to y. Let's see what happened. So all right, it's correct. X to 4 and ex square y and plus 6xy, right? Okay, sorry for that. We are 30 minutes late because I have done something wrong in one question, in one answer, right? See you next time, right? See you next time, and okay, the homework will be something about the 5th chapter, right? Okay, see you on next Thursday, right? บ๊ายบายครับ สวัสดีครับ and what happened? And oh, what? Oh, finish even. These two